Hi, I'm going to provide a quick demonstration on how to use Liquid XML data binding with C++. XML data binding enables you to read, modify, and write XML documents using a strongly typed object model from your chosen programming language. I'm going to start with an XML schema called bookstore.xsd and an XML document which is valid against the schema called bookstoresample.xml. If I open the bookstore.xsd in Liquid Studio, we can see the root element bookstore is of type bookstore type, and this contains a collection 0 or more books. Each book is of type book type. Book type has child elements such as title, author, and attributes such as price. If I open the XML document bookstoresample.xml, we can see it contains data for the bookstore, such as book, which has a price attribute, and the child elements we store in the XML schema. If I click Validate Document, we can see the XML document is valid against the bookstore schema. So what I want to do is to load this document into a program, modify it and serialize it back to disk. But I don't want to use a generic technology such as DOM or SAX parser that deals with untyped nodes. Instead, I want to use a strongly typed API to enable me to load the document into an object model which I can access from a C++ application, something that I'm used to doing as a software developer. If I go back to the bookstore.xsd, I can click Generate Code. This launches the Liquid XML data binding wizard. I could also run the wizard from the desktop icon or via the command line interface. First, I need to select C++ as the output language. The next screen already pre-selected our bookstore schema. Next, I need to save the XML data binder project file. The next screen enables me to select the top-level elements of the schema for which I want to generate code. The bookstore only has one root element, so I'll select that. On this next page, I can change the name of the default C++ class namespace for the generated code. I can also set the default naming for collections. I'm going to select the Append Call to Name option. This will help me differentiate collections from other generated classes. If I want to make more detailed changes to the way the generated classes are named, I can click the Change Schema to Object Mapping button. This displays all of the classes that will be generated. So we have a book type, which has C++ attributes, price, title, author, etc. This allows me to change the generated methods for items such as the getters and setters. Next, I can set the output folder for my generated code. And I can also choose to generate HTML documentation that describes my API and object model. I can also select the option to generate a sample application, which provides a good starting point for coding. In here, I can select to add our bookstore sample XML document, which we'll see in the code later. So now the wizard has generated my source code and HTML help, it gives me the option to compile the help into a Windows help file and to open the generated project. As I have multiple copies of Microsoft Visual Studio installed, I can also pick which version to open. I'll choose Visual Studio 2022. The help file has been compiled and opened. This is a standard Windows help document, but the pages generated are just standard HTML. It shows me the classes that have been generated along with the schema which they were generated from. The classes include the book type class, which has a price, title, author, etc. As you can see, it also provides a sample usage for the property. The wizard also launches Microsoft Visual Studio with the generated solution that contains the generated class library, bookstore lib, along with the sample application. So let's just run the sample application. The output window shows the contents of the Bookstore sample XML document. So what's happened? Well, a good place to start is in the source code of the sample app. Inside the main function, we can see that this test function is being called, and the path to the Bookstore sample XML document is getting passed in as a parameter. The test function demonstrates loading data into and writing data from our generated object model. The first thing it does is create a Bookstore object. All objects are created as smart pointers. Smart pointers act as containers for the actual objects and use reference counting to automatically delete the object when it is no longer required, helping to prevent memory leaks. If I go to the definition, we can see the Bookstore class. This is a generated class derived from a common base. We can also see that the Bookstore has a book collection. This is a strongly typed collection of book type objects. As you can see, this object model represents the data defined in the bookstore.xsd and provides an easy-to-use mechanism for holding the XML data that is valid and compliant to the rules of the XML schema. Going back to the sample application, once it has created the Bookstore object, it then uses the FromXML method to load the sample XML document. It then uses the toXML method, which returns a string representation of the data in the object model and writes this to the output console. The code also demonstrates the toXML method, which will write the object model data out to disk, and the toXML stream method, which returns the object model data as a binary stream. But what about modifying the data held in the object model? Well, once the data has been loaded into the model using FromXML, I can then change the objects in the object model in memory. First, I'm going to get the book collection from the Bookstore element using getBook. I can now add a new book using the add method. The book is of type book type. Notice the book is in the BS namespace as it is in the XML schema. One of the main advantages of XML data binding is the strongly typed nature of the object model. This allows us to use IntelliSense in Visual Studio. So if I type book, we can see all of the methods available on the book object. So I can go ahead and set the title. The book also has an author. Now I may think that author is also a simple string, but straight away I get the hint telling me it isn't and that it requires an author name object. Now if I rerun the application, we can see that the additional book item has been added to the book collection with the values I specified in the code. Although we did not specify a value for price, as price is a mandatory attribute, the default value is included automatically to ensure the document is valid against the schema. So to summarize, using Liquid XML data binding simplifies the task of creating and modifying XML documents. It is much easier to use and significantly less error-prone than generic technologies such as a DOM or SAX parser. Using strongly typed nodes means that you will be more productive, enabling you to focus on writing your business-specific code and help you to deliver your project on time. For more information, please see our website. Thank you for watching.